Second part of previous year question paper with a detailed solution of ISRO Space Application Center Technician B Electronics, the exam held in 2018. The question booklet series is A. Up to question number 23, we discussed in the part 1 video. So consider question number 24. A digital circuit that can store 1 bit is a answer is option B, flip-flop. In electronics, a flip-flop or latch is a circuit that has two stable states and can be used to store information. A flip-flop stores a single bit binary digit of data. One of its two stores a 1 and other represents a 0. Gate. Logic gate can be used in technologies such as smartphones, tablets or within memory devices. In a circuit, logic gate will make decisions based on a combination of digital signals coming from its input. Most logic gates have two inputs and one output. Logic gates are based on Boolean algebra. XOR gate. The XOR or exclusive OR gate act in the same way as in the logical either or. The outputs are true if either, but not both, of the inputs are true. The output is false if both inputs are false or if both inputs are true. This is a truth table of XOR gate. Register. A register is a collection of flip-flops used to store binary data and manipulate it using control signals. The architecture of a register consists of mostly memory storage, allowing it to store data temporarily or permanently. 25. FETs consist of answer D, all the above, drain, gate, source. These three are the three terminals of FET. FET is a device that relies on the electric field to control the shape of the channel, therefore on the conduction of the channel, hence referred to as field-effective transistor. FET is a unipolar transistor that involves only one type of charge carriers in its operation. Example in JFET, the current flowing through the channel between drain and source is controlled by the voltage applied to the gate terminals, which is reverse biased. 26. How many coulombs of charge will flow through a circuit carrying a current of 10 ampere in 1 minute? Answer is option C, 600. The amount of charge that flows through a circuit Q equal to IT. That we know I equal to Q by T. So rearranging the equation, we get Q equal to I into T, where I is the current in amperes and T is the time in seconds. Therefore, the charge that flows through the circuit Q equal to 10 ampere into 1 minute means 60 seconds. Substituting this, we get Q equal to 600 coulombs. In a microprocessor, ALU stands for arithmetic and logic unit. An arithmetic and logic unit is the part of a central processing unit that carries out arithmetic and logic operations on the operands in computer instruction words. 28. Arsenic is dash element. It is a pentavalent element. Doping is a process of adding impurities to intrinsic semiconductors to alter their properties. Normally, trivalent and pentavalent elements are used to dope silicon and germanium. When an intrinsic semiconductor is doped with a trivalent impurity, it becomes a p-type semiconductor. Pentavalent impurity. The pentavalent impurity atoms have 5 valence electrons. These 5 valence electrons are named nitrogen, phosphorus, arsenic, antimony and bismuth. Trivalent impurity. The trivalent impurity atom has 3 valence electrons. Example, indium, gallium, aluminium, boron, etc. As trivalent impurities accept electrons from the covalent bonds of silicon, germanium, they create p-type semiconductor. The color of light emitted by a LED depends on the type of semiconductor material used. Answer. The color of the light emitted by the LED depends on the wavelength of the light, which in turn depends on the semiconductor material used in the diode while manufacturing the LED. Question number 30. Find out the current flowing the resistor R4 after switch S is closed. Answer is option B, 0.15 ampere. After closing the switch, the circuit becomes like this. Here R1 and R2 are in series. Then the circuit becomes R12, equivalent resistance R12 equal to 6 ohm plus 4 ohm, which is 10 ohm. Then the circuit becomes like this. Here R12 is in parallel with R3. Then the circuit becomes like this. That is R123 equal to R12 into R3 divided by R12 plus R3. That is 10 into 15 by 10 plus 15 equal to, we get R123 equal to 6 ohm. Substituting this, the current in series combination connection is same. So the current through R4 and R12 are same. So by Ohm's law, I equal to V by R. Here V is 1.5 volt and equivalent resistance R equal to R4 plus R123, which is 10 ohm. We get I equal to 0.15 ampere. Identify the symbol. This is a symbol of tunnel diode. A tunnel diode is a semiconductor diode that exhibits negative resistance, meaning the current decreases with an increase in voltage. By making use of quantum mechanical effect, the tunnel diode is capable of fast operation and can function well into the microwave radio frequency band. A tunnel diode is a heavily doped PN junction diode in which the electric current decreases as the voltage increases. In tunnel diode, electric current is caused by tunneling. The tunnel diode is used as a very fast switching device in computers. It is also used in high frequency oscillators and amplifiers. That is, it is used in different oscillators like relaxation oscillators and microwave, etc. Application of tunnel diode. It is used as a memory, logic memory storage device, switching device with very high speed, microwave oscillator with a high frequency, used as an oscillator, amplifier and switch. Varactor diode. It refers to the variable capacitor diode, which means the capacitance of the diode varies linearly with the applied voltage when it is reverse biased. This is a symbol of the varactor diode. The junction capacitance across a reverse biased PN junction, C equal to A epsilon by W, where A is the area of cross section, W is the depletion region width and epsilon is the permittivity. As the reverse bias voltage increases, the depletion region width increases, resulting in the decrease in the junction capacitance. Applications of varactor diode. It is used in tuned circuits, FM modulators, automatic frequency gain control circuits, adjustable bandpass filters, parametric amplifiers. Zener diode. It is a semiconductor device that allows current to flow in both directions, but specialize in current flowing in reverse. Also known as breakdown diodes. Zener diodes are most common electronic components used as stable voltage reference for electronic circuits. This is the symbol of Zener diode. Under small forward bias voltage in tunnel diode, the forward resistance is, answer is option C, very small. The tunnel diode is a highly doped semiconductor diode. The Fermi level moves in the conduction band to the N side and inside the valence band on the P side. Below the Fermi level, all states are filled, and above the Fermi level, all the states are empty. Let us analyze this working of diode. At zero bias, there is no current flow, as in the Fermi levels are aligned. We can see that one side is N type and another is the P type. Step 2. A small forward bias is applied. The potential barrier is still no noticeable injection and a forward current through the junction. However, electrons in the conduction band of the N region will tunnel electrons to the empty regions of the valence band in the P region. This will create a forward bias tunneling current. Here first is the P region and the second one is the N region. Step 3. With a larger voltage, the energy of the majority of electrons in the N region is equal to that of the empty states or holes in the valence band of P region. This will produce maximum tunnel current. This we can identify from the VI cara. Forward bias continues to increase. The number of electrons in the N side that are directly opposed to the empty states in the valence band in terms of their energy decrease. Therefore, the decrease in the tunneling current will start. Step 5. More forward voltage is applied. The tunneling current drops to 0. But the regular diode forward current due to electron hole injection increases due to a lower potential barrier. Step 6. With further voltage increase, the tunnel diode VI cara is similar to that of a regular PN junction. Step number 7. Under reverse bias, electrons in the valence band of the P-type tunnel directly towards the empty state present in the conduction band of the inside, creating large tunneling current which increase with the application of reverse voltage. This also we can see from the VI Cara. Question number 33. Calculate the total inductance of the following circuit. Answer is option A, 9 millihenry. Consider the circuit. L3 and L4 are in parallel. Therefore, 1 by L34 equal to 1 by L3 plus 1 by L4. Therefore, L34 equal to L3 into L4 divided by L3 plus L4. We get answer 30 millihenry. Now, L34, L1 and L2 are in series. So, L total equal to L34 plus L1 plus L2. That is, we get L total as 90 millihenry. 34. A 100 microampere meter movement with an internal resistance of 800 ohm is used in a 0 to 100 milliampere ammeter. Find the value of the required shunt resistance. Answer is option D, 0.8 ohm. Given internal resistance of coil Rm equal to 800 ohm, total current I equal to 100 milliampere, full scale deflection current Im equal to 100 microampere. We know the equation of shunt resistance RSH equal to Rm divided by I by Im minus 1. Substituting the values of Rm, I and Im, we get shunt resistance RSH equal to 0.8 ohm. Which of the following is known as equivalence logic? Answer is option A, XNOR. The XNOR gate is a digital logic gate whose function is the logical complement of the exclusive OR gate. The two input XNOR complements logically equality, and hence the gate is sometimes called as equivalence or coincidence gate. A high output one results if both the inputs to the gate are same. If one but not both inputs are high, the low output results. Truth table shows the truth table of the various options given in the question. It is not one, it is A. Input A and B. The truth table of XNOR, XOR, NAND and NOR is given. Identify the symbol. The symbol is of IGBT. That is option D is the correct answer. IGBT, insulated gate bipolar transistor. It is a power transistor that combines an input MOS and an output bipolar transistor. This we can identify from the figure. The most basic function of an IGBT is the fastest possible switching of electric currents, thus achieving the lowest possible switching losses. As the name insulated gate bipolar transistor reveals, an IGBT is a bipolar transistor with an isolated gate structure. The gate itself is basically a MOSFET. The advantage gained by the IGBT device over a BJT or MOSFET is that it offers greater power gain than the standard bipolar type transistor combined with the higher voltage operation and lower input losses of the MOSFET. IGBTs are mainly used in power electronic applications such as inverters, converters and power supplies. Power MOSFET. A power MOSFET is a specific type of MOSFET designed to handle significant power levels compared to the other power semiconductor devices such as an IGBT or a thyristor. Its main advantages are high switching speed and good efficiency at low voltages. The power MOSFET has a vertically oriented 4-layer structure of alternating P and N types layers. That is N plus, P, N minus and N plus. The P-type middle layer is called as body of MOSFET. In this region, the channel is formed between source and drain. The N layer is called as drift region, which determines the breakdown voltage of the device. The power MOSFET is the most common power semiconductor device in the world due to its low gate drive power, fast switching speed, easy advanced paralleling capability, wide bandwidth, ruggedness, easy drive, simple biasing, ease of application and ease of repair. Application: power supplies, DC to DC converters, low voltage motor controllers, etc. LDR. This resistor works on the principle of photoconductivity. It states that when the light falls on the surface of an LDR, the conductivity of the material reduces. This is the symbol of LDR. This is because the photons in the instant light have energy greater than the band gap of the semiconductor materials used in the LDR. It is a passive component that decreases resistance with respect to receiving luminosity, that is light on the component sensitive surface. These devices are used where there is a need to sense the presence and absence of light is necessary. These resistors are used as light sensors, and the applications of LDR mainly include alarm clocks, street lights, burglar alarm circuits. PHEMT, pseudomorphic high electron mobility transistor, is one technology monolithic microwave integrated circuit MMIC designers and fabrication used to develop and manufacture microwave integrated circuits. 37. A Darlington pair has dash input impedance. Answer is option D, very high. Darlington pair transistor. This is the equivalent circuit of Darlington pair transistor. It is a special arrangement of two standard NPN or PNP bipolar junction transistors connected together. The emitter of one transistor is connected to the base of the other to produce more sensitive transistor with a much larger current gain, being useful in applications where current amplification or switching is required. Both the collector terminals are connected to the common terminals. Darlington pair combination is a common collector connection. A Darlington pair configuration has high input impedance, low output impedance and high current gain. Thus, it is used as a buffer circuit for impedance matching with the circuits that require high input impedance at the input. The current gain of a Darlington pair in common emitter configuration is approximate beta square. Darlington pair emitter follower circuit is sometimes used in the output stage of TTL gate to increase the speed. 38. Decibel is a power of. Answer is option A, power levels. Decibel is a logarithmic unit used to measure sound level. It is also widely used in electronics, signals and communication. The dB is a logarithmic way of describing a ratio. The ratio may be power, sound pressure, voltage or intensity or several other things. 39. Which of the following is used for measurement of dielectric loss of capacitance? Answer is option B, shearing bridge. The shearing bridge used for measuring the capacitance of the capacitor, dissipation factor, properties of an insulator, capacitor bushing, insulating oil and other insulating materials. It is one of the most commonly used AC bridge. The shearing bridge works on the principle of balancing the load on its arm. AC bridge, name of the bridge and the use. Maxwell's inductance capacitance used to measure of inductance. Suitable for medium Q coil 1 less than Q less than 10. Hayes bridge for inductance. Suitable for high Q coil Q greater than 10. Slowest bridge. Anderson's bridge inductance. 5-point bridge Q less than 1. Accurate and fast bridge. Owen's bridge for inductance used for measuring low Q coil. De Sauty's bridge for capacitance suitable for perfect capacitor. Shearing bridge used for capacitance used to measure relative permittivity dielectric loss. Wayne's bridge for capacitance and frequency. Harmonic distortion analyzer used as a notch filter used in audio and high frequency application. Heaviside mutual inductance bridge used to measure mutual inductance. Campbell's modification of Heaviside bridge also used to measure mutual inductance. DC bridge, Wheatstone bridge used for medium resistance. Corey-Foster's bridge, medium resistance. Kelvin double bridge for very low resistance. Megger, high insulation resistance, that is resistance of cables. Loss of charge method, very low resistance. 40. If a radio station is broadcasting at a 98.3 MHz, then the wavelength is approximately. Answer is option D, 3 meter. Given frequency f equal to 98.3 MHz, which is equal to 98.3 into 10 raised to 6 Hz. The relation between velocity, frequency and wavelength C equal to f lambda. We know the velocity of light C equal to 3 into 10 raised to 8 meter per second. Therefore, wavelength lambda equal to C by f. Substituting the value of C and f, we get wavelength lambda equal to 3.05 meter. Note: wavelength is equal to the distance travelled by the wave during the time in which any one particle of the medium completes one vibration about its mean position. It is length of one wave. Frequency, it is defined as the number of vibrations completed by the particle in 1 second. That is, it is a number of complete wavelength traversed by the wave in 1 second. 49. What is a LDR? Light dependent resistor is the answer. This resistor works on the principle of photoconductivity. It is stated that when the light falls on a surface of an LDR, the conductivity of the material reduces or changes. This is because the photons in the instant wave have energy greater than the band gap of the semiconductor material used in the LDR. This is a symbol of LDR. It is a passive component that decreases resistance with respect to receiving luminosity, light on the component sensitive surface. These devices are used where there is a need to sense the presence and absence of light is necessary. These resistors are used as light sensors, and the applications of LDR mainly include alarm clocks, street lights and a burglar alarm. 7200 millivolt is same as answer is option B 7.2 volt. 1000 millivolt equal to 1 volt. Therefore 7200 millivolt equal to 7.2 volt. Identify the waveform. This is the waveform of a triangular wave. Triangular wave is a non-sinusoidal waveform named for its triangular shape. It is a periodic, piecewise, linear and continuous real function. Sawtooth wave. This is the sawtooth wave. It is a wave. This wave is a kind of sinusoidal waveform. It is so named based on its resemblance to the teeth of a plain-toothed saw with a zero rake angle. Ramp signal is also mostly same. A single sawtooth or an intermittently triggered sawtooth is called ramp waveform. A ramp function or ramp signal is a type of standard signal which starts at t equal to 0 and increases linearly with time. The unit ramp function has unit slope. 44. In a 5-branch parallel circuit, there are 12 milliampere of current in each branch. If one of the branches opens, the current in each of the other branches is, answer is option B 12 milliampere. All 4 branches are connected in parallel, so the voltage across every branch is the same. If one of the branches is open, it does not affect the other branch's current, because the voltage and impedance across the remaining branches will remain the same. 45. Current 3.2 into 10 raised to minus 5 ampere is equal to 32 microampere. We know 10 raised to minus 6 ampere which equal to microampere and 10 raised to minus 3 ampere equal to milliampere. Therefore 3.2 into 10 raised to minus 5. We can convert into microampere by multiplying and dividing with 10. We get 32 into 10 raised to minus 6 which is equal to 32 microampere. The last question in this video is 46. A permanent magnet will not attract. Answer is option D copper. Materials that are not attracted towards magnet are called non-magnet materials. In their natural state, metals such as aluminum, brass, copper, gold, lead and silver don't attract magnets because they are weak metals. Thank you.